Anyway, so back to the point of this. We're going to compare linear, quadratic, and exponential functions today by looking at their t-tables and graphs. So this time I have f of x equals 2 times x squared, because I'm actually doing the right paper with you this time. I'm going to do 2 times 5 squared, which is how much? 50. Thank you. 2 times 6 squared? 72. 2 times 11 squared. Anybody wondering where we're getting this? We're just punching them in the calculator. Squaring 11, times them by 2, or punching it in exactly the way that it looks. Yep, 140. 242, right?
Yeah, 121 times 2.
Yep. Okay, putting 12 in. 12 squared times 2. 288. And then 13 squared times 2. Yep, 338. Nice. So that's not too bad, right? Just filling in a t-table. We're going to do the same thing now for the g of x function. This time g of x is an exponential function, but I still substitute the x value in place of the x. So 2 to the 5th power is, nice, 2 to the 6th power, 2 to the 11th power, it's big,
2048.
2 to the 12th power, anybody get that? 4096. And then 2 to the 13th power is exactly.
I think you're trying to suicide my grade, Miss Clark.
Okay. So really all we did was we substitute these x values in place of x, and we found a whole bunch of ordered pairs. This would be 11, 242 for the f function, 11, 2048 for the g function. So we found a whole bunch of ordered pairs. So now what we're going to do is we're going to come over and see if we can answer the questions about the table that we just made. So it says in the table when x is greater than or equal to 6. So we're going to look in the table. Thank you. Where x is greater than or equal to 6. So those are my only table values that are greater than or equal to 6. Do you guys agree with me on that? It says when we're looking at the table, f of x is always less than g of x, sometimes less than g of x, or is never less than g of x. So we're going to look at the f of x values, and we're going to compare them to the g of x values, and we're going to decide which one of those statements is true from looking at those values. So what do you think? Here the f value is bigger than the g value, right? Do you agree with me? F is bigger here, but then it's smaller, smaller, smaller. So which one of those answers do I have to have? Is it always less than g of x? Is it sometimes less than g of x? Or is it never less than g of x? It's sometimes, because of that one that was less than, and then the rest of them were bigger than. Okay? Number 2 says which function has the bigger rate of change. Does anybody remember how we find the rate of change? We use the slope formula, right? These are both my x values. We've done this before. It wants to know which function has the bigger rate of change over the interval from 6 to 12. So an x value of 6 and an x value of 12. I'm going to come over here. How do you know g of x?
Because it goes into the power and not just
Okay.
squared by the multiple.
Okay. I like your thinking. Anybody else know for sure that it's g of x? I'm going to show you the math behind it. I'm not going to disagree with Charlie right there. If I were looking at these, I'd be looking at the huge change in y's. Are you seeing the big change in y's compared to the smaller change in y's? That should really automatically tell you that the slope is going to be bigger on this one, right? Because there's a bigger change in y. But I want to remind you, if you can't remember how to do that, do your change in y's over your change in x's for these ordered pairs. So your x value of 6 and your x value of 12. So even though Charlie's already told us what we think is true, I'm going to do the math behind it really fast to show you. So on the f function, my 6 value goes with 72. And on the f function, my 12 value goes with 288. And why did I grab the 6 value and the 12 value? It's because that was the interval that they told me to look at. Then I just have to punch it into the slope formula. So 288 minus 72 over 12 minus 6. Okay. And when you do that math really fast, you're going to just get one nice number. So do that for me and tell me what you got. Yeah, it is 36. So my rate of change on the f function is 36. Now, I think that you could probably already tell, just like Charlie said, it's going to be bigger on this one, because do you see how big it's changing? But it's really fast. Again, I just want to show you how the math works. I'm going to go grab my g value at 6, which is 64. And I'm going to go grab my g value at 12, which is 4,096. And I'm going to do the slope formula. So 4,096 minus 64 over 12 minus 6. What do you think? Do you think it's going to be bigger for sure? Like quite a bit bigger, right? When you do that, you get the answer of 672. So Charlie was right about that, you guys. It for sure has the bigger change. And you can tell that by looking at the huge change in the y values compared to the change in your x values. Okay, so to answer the question, which function has the bigger rate of change? It would be the g of x function. Now, I'm not going to tell you you have to do this work, but I'm going to tell you if it's close enough you can't tell, do the work. Does that make sense to everybody? All right, number 3 says the graph of f of x is what kind of a graph? A parabola, a line, or an exponential graph? Okay, look at the power of 2. So it has to be a parabola. You're right. Okay. Questions on how we did that part? Okay. Now on the worksheet today, it's going to ask you to graph a couple of these things. So I want to remind you how to graph this parabola really fast. So if you have that parabola that says f of x equals 2x squared, I just want to remind you really fast how to graph that. Is there any left or right movement? No, because there's nothing added or subtracted to the x. Is there any up or down movement? No, because there's nothing added or subtracted to behind the x. So I start at 0, 0. So what the heck is that 2 there for? Does anybody remember what happens with that 2? It changes my pattern. So my pattern is usually over 1, up 1, over 1, up 3. But I'm going to change my pattern by timesing it by 2. So I would do 2, 6, 10. So over 1, up 2. Over 1, up 6. And your parabola goes through those ordered pairs. Do you remember how we do that with the pattern change? Then just a reminder how I would graph this. The only way I showed you how to do that was with a t-table. We picked 1, 0, and -1. We plugged them in to get our ordered pairs, right? So we could totally graph those. All right, second set of functions that we're comparing. Anybody know what this one's a graph of? That's a line, good. And this other one right here is going to be a parabola. What do you think is going to grow faster, the line or parabola? Anybody have a guess? Yeah, I don't know. Let's compare the numbers and see, should we? Okay, we're going to put -4 in here every time we see an x. So 2 times -4 minus 5 gives me how much? -13, good. 2 times -2 minus 5? Perfect. 2 times 0 minus 5? -5. -5. 2 times 2 minus 5? You guys are awesome at this. Thank you. 2 times 4 minus 5.
3,
And then 2 times 6 minus 5.
7,
Perfect. Okay, that was really fast, but you guys did awesome on that. We're going to do the same thing here. We're substituting the number in place of x. So negative 4 plus 1 squared.
-3,
Okay, inside is negative 3, and negative 3 squared would be negative 3 times negative 3, which is positive 9. Good. So negative 2 plus 1 squared. This would be negative 1. Negative 1 squared is positive 1. Good. This will be 0 plus 1 squared, which is 1. 2 plus 1 squared.
no, just positive.
Yeah, positive 9. And then it will be 4 plus 1 squared.
So 25,
Perfect. And 6 plus 1 squared.
49,
49. Beautiful. Okay, we're going to use that set of values to answer our questions over here. Number 1 says the graph of f of x is a parabola, line, or exponential. We already said it was a line, right? Because the power was 1. So the first answer is line. All right, number 2 says g of x is always bigger than f of x, sometimes bigger than f of x, or never bigger than f of x. So we're looking at this one compared to that one. Is 9 bigger than 13 negative?
yeah,
Yeah, what about here?
it's always bigger.
It is always bigger. G of x is always bigger than f of x. And why is that?
Because they're either positives or they're negatives.
Yeah, it's because you squared it, right? And when you square the number, you're always going to get that positive out. So these ones were always bigger than f of x for comparing those two functions. Okay, this last part then asked me what's the rate of change of g of x. This one's nice. I only have to find it for g of x from 0 to 2. So I'm going to come over and I'm going to grab my ordered pairs that have to do with 0 and have to do with 2 on my g of x function, right? Because I'm only looking at g of x. So what's my ordered pair at 0 for g of x? 0, 1. And what's my ordered pair at 2? 9. Then I'm going to just punch it through my slope formula. So y2 minus y1 over x2 minus x1. And I'm really just going to do that math now. On the top, what do you get?
Negative 8.
Ooh, positive 8, right? Because the 9's positive. On the bottom, you get 2. When you divide it, you get 4. So the rate of change over the interval from our x's of 0 to our x's of 2 would be the number 4.